Okay, is it safe to assume we're around the table again today like usual? Were any of them that you all got by yourself that you don't need help with? Perhaps a little Christmas miracle? No? All right, so let's ooh, this is a lot, 10 pages. All right, it says a hot air balloon takes off from the edge of a plateau. So we have done this one before. We did this in the examples from the notes, right? Impose a coordinate system as pictured below and assume that the path of the balloon follows is the graph of the quadratic function, blah, 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 blah. The land drops at a constant incline from the plateau at the rate of 1 vertical foot for each 5 horizontal feet. So if the ground is dropping 1 vertical foot for every 5 horizontal feet, what is the slope of the
1/5
ground? Right, negative 1/5. So since we have imposed the coordinate system to have this be where we take off at 0, 0, what's the equation for the ground? Y equals negative 1/5 x, because our y-intercept would be 0, right? All right, so now we are ready to answer some questions. What is the maximum height of the balloon above plateau level? All right, so I think I feel like we kind of screwed this up when we did the notes. The distance that the balloon is going to be from the ground, since the ground is not flat, is going to be this equation here minus this one right there. How do you feel about that? No? No. Okay. Does that seem right? Because normally the equation is y equals 0, but this time we have this slant. Okay, good job. All right, so I need to go negative 4 over 2,500 x squared plus 4/5 x minus negative 1/5 x. And that's handy because 4/5 x minus negative 1/5 x is how much? 1x. Okay, whoops, that's supposed to be squared, sorry. So this is negative 4 over that x squared plus x. So how do I find where the maximum height above the ground is? Right, the x coordinate of the vertex will tell me where. So that's going to be negative b over 2a, right? What? Negative 1 over
4, negative 4 over 12.
Good, negative 4 over 1250, because half of 2,500 is 1,250, okay? So negative divided by negative is a positive, and 1 over fraction does what to the fraction? Flips it over. So that means my x coordinate is going to be 1250 over 4, which is what? Not a whole number, but it's not going to be bad. It's going to be a 0.5, I think. 312.5? Okay. All right, so that is the, what's plateau level? Oh, so I screwed that up already. It says, what is the maximum height of the balloon above plateau level? So this equation tells you the height above plateau level. I guess that's the flat thing. B says, what is the maximum height of the balloon above ground level? That's what we just did. Okay, so this is actually B. Okay, but we didn't actually find the maximum height. We just found where that maximum height occurs. What do I have to do with that to find what the maximum height is? Plug it into the original equation. So I need to say y equals, and take and plug that in to the original equation, which I'm going to do on a calculator. So negative 4 over 2,500 times, what did we get for the x? 312.5? Times 312.5. And then what came after that? Plus x? Oh, yeah, thank you. Squared. All right. Plus x.
With the original.
We're still doing this equation right here. Okay, so plus 312.5. Okay, so the maximum height the balloon will be above the ground is 156.25 feet. Allie, are you checking and making sure we're doing these right? You did the other day. It's always good. All right, and then for part A, it says what is the maximum height of the balloon above plateau level? So now I don't worry about the whole ground thing. 100 feet? For A or B? Oh, we just did B. Okay, so now we already know what the answer to part A is. Yes. Just write that down. No, I'm just kidding. Okay, so trying to get 100 feet. All right, what is the maximum height of the balloon above plateau level? Now we're going to just take the original equation and do the same thing. So the x-coordinate of the vertex is negative b over 2a. So I'm going to go negative b is negative 4/5. Divided by 2a is once again going to be negative 4 over 1250. Okay, resheet your calculators. What do you do when you divide two fractions? Multiply by the reciprocal, so I'm going to go negative 4/5 times negative 1250 over 4. Okay? So conveniently, the 4's cancel, the negatives cancel, and 1250 divided by 5 is 250. All right, so that's the x value where the maximum height of the balloon is above the plateau. What do I do with that? And what do you think we're going to get? 100. Okay, good. So the answer to that is 100 feet. All right. All right, then we need to figure out where the balloon lands on the ground. How do you do that? How do you do that? Huh?
Plug in the your y equals thing, put in both equations.
And then we do what with them?
See where it's from.
Yeah, right. Basically what we're trying to do is we are trying to find the intersection point between the ground equation and the balloon equation. Okay, so one way that you can do those is you can graph both the equations and then use the calculator feature to find where they intersect. Okay, or you could be a good math student and you could do it algebraically by setting them equal to each other. So the first equation is negative 4 over 2500 x squared. Is it plus 4/5 x?
Yeah.
Okay, and we want to figure out when that equals negative 1/5 x. So how would you solve that? Add it over to the other side. So I get negative 4 over 2500 x squared plus x equals 0. How do you? We could go quadratic formula, but I don't want to because there's an easier way. I'm not going to graph it because that's cheating. I'm not going to use the matrix. There you go, looking for the F word. I'm going to factor. Okay? No, I'm not going to completely square. We could do that though. All right, so I can factor out an x. So that gives me negative 4 over 25,000x plus 1 equals 0. And this should make sense because the first answer that I would get with this right here is that x equals what? 0, which is because the balloon started on the ground. So that's where it started on the ground. The next answer I get is if I set this thing right here equal to 0. All right. What do I do from there?
I subtract 1, make it positive.
Okay, so I'm going to subtract 1. So negative 4 over 2500x equals negative 1, and then you want to make them both positive, so what you said. All right, how do I solve that for x? Multiply by L reciprocal. So 2500 over 4, we already decided that was, did we do that already? 12. No, we didn't. 312.5?
Well,
Oh, that was half of that.
So
Yeah.
it's 625.
625.
Yeah.
Yeah. All right, so it hits the ground 625 feet from where it started. Okay? All right, and then the last one says, where is the balloon 50 feet above the ground? Where is our equation that shows how far the balloon is above the ground? Which one of these things does that?
That one.
This one?
Yes.
Right, because that's where we subtracted the height above the plateau from the ground. So what do I need to do with this to find out when it's 50 feet above the ground? Set it equal to 50. Okay. So -4 over 2500 x squared plus x. We want to figure out when that equals 50. Now I think, unfortunately, we have to go quadratic formula. How do I solve that to start with? Subtract 50 from both sides. Oh, you guys have this on your calculator, so you'll be okay. So -250 x squared plus x minus 50 equals 0. So somebody have that quad program on the calculator? You got it? Okay, so what do you get for x? Should get two answers because there's two different times.
54.81 and 570.2.
570.2. All right, so both of those places, in theory, will be where the balloon is 50 feet off the ground. What number is this? 7? 4.81. And what's the other one? 570. Yep, winner, chicken dinner. All right, we good? Check. All right, next one. Oh my gosh, this is just evidence that you didn't even try and do your homework. Suppose f of x equals 3x squared minus 2. Does the point 1, 2 lie on the graph? What do you do with that? Plug it in. 3 times 1 squared minus 2 is 1. So does that point lie on the graph?
Yes.
No. When I plug 1 in for x, I don't get 2 as an answer. So that's a big fat no. Okay, thanks for putting out your effort. Yeah, but that's part A, so there's going to be more misery to come. Okay. What? We okay? Did I do something wrong?
I thought 3 equals 3. Break it down.
No, if you plug in 1, then the answer that you get is what y equals when x equals 1. So like if I plug in 0, I get -2, so that means the point 0, -2 is on the graph. It'd be like if you're making a table or something like that. Okay. All right, I'm going to assume it's going to get a little bit more complicated here. If b is a constant, where does the graph of, where does the line y equals 1 plus 2b intersect the graph of y equals blah, 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 blah? How do we do that? Set them equal to each other. So 1 plus 2b has to equal x squared plus bx plus b. What do we do now?
We'll subtract b.
You want to get it all over on the left?
I mean, we can just subtract b from the right.
Yeah, can we get it all over here on the right, since that's where my quadratic is? So it's going to be x squared plus bx. b minus 2b is -b, and then -1 is -1. So now I need to solve that. How do I do that? Really? I think you do have an idea. Quadratic formula will work, right? A is, there's not though. A is 1, B is, oddly enough, B, and C is this whole thing right here, -b minus 1, because it says b is a constant. Okay? So it's a little bit different than we've done before, but big kids, you can handle it. So opposite of b is negative b plus or minus the square root of b squared, so that would be b squared, minus 4 times a, which would be 4 times c. So 4 times negative b minus 1. All a is 1. All over 2a, so that would be over 2. All right, so just a little bit of simplifying that we can do, but not much. If I distribute this 4, I get 4b plus 1 all over 2. 4b plus 4, thank you. All over 2. This is exciting. What do we have here underneath the square root?
Perfect square.
Perfect square trinomial. So I can take this and factor it into b plus 2 times b plus 2.
So it's just b plus 2.
So it'll be, yeah, you're a step ahead of me, b plus 2 squared over 2. And then the square root of b plus 2 squared is b plus 2. So the fun keeps going. So it's really negative b plus or minus b plus 2 over 2. So if I go negative b plus 2, the negative b and the plus b will cancel, right? And 2 over 2 is 1. So that's one of my answers. And then if I go negative b minus b, I get negative 2b minus 2 all over 2. So negative 2b minus 2 over 2 is really negative b minus 1. Okay? So that turns out to be pretty exciting, huh, Megan? You look pretty excited over there. As usual, totally engaged. All right, keep going. If a is a constant, where does the line y equals 1 minus a squared intersect the graph of blah, 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 blah? What do we do with this?
Not anything, we'll skip it.
Set them equal to each other. So x squared minus 2ax plus 1 equals 1 minus a squared. Huh? What do we do now? They all run one side. So x squared minus 2ax, the 1 and the 1 cancel, and then when I bring the negative a squared over here, it will be positive a squared, which is 0. Okay? All right, so now we're going to do the same thing again. So a is equal to 1. B is equal to negative 2a. And c is equal to, nope, a squared. All right? So now we're going to go around again. So x equals the opposite of b, which is positive 2a, plus or minus the square root of b squared. What's this thing squared? 4a squared minus 4 times 1 times a squared, Uterus. Oh, more fun things happen all over just 2a. 2, just over 2. And so what do I get underneath the square root here? 0. 4a squared minus 4a squared, 0. So 2a over 2 is a. Okay? Hi, Emily. How are you? Good. Okay, so let's play again. Now it says where does the graph of y equals negative 2x squared plus 3x plus 10 intersect the graph of x squared plus x minus 10? What are we going to do?
Set them equal to each
Set
other.
them equal to each other. So how do you solve that?
Subtract one on the right.
You want to get everything, how do you want to get everything on the left or the right?
On the left.
On the left?
To the left, to the left.
Okay. So that means this is going to be negative 3x squared. Hey Miranda. And then if I subtract an x, that's going to be, hold on just a second, 2x. And then if I add 10, that's going to be 20. And that has to equal 0. Okay? So you guys, now we don't have any weird a's or b's in there. So we can just go quadratic formula on your calculator and find out what x is from that. What'd you say? Yep. What do you got?
Negative 2.27
And 2.94. All right, and I'm guessing probably they wanted us to save it as a square root thingy or something. Oh, no, they have negative 2.27 and negative, I'm sorry, 2.94. Yep. Okay, thanks. What just happened, Kenny? Did you get disrespected in some way?
Yeah,
No, we're friends.
Did she not act in a friendly manner? All right, number 15. Two particles are moving in the xy plane. They move along straight lines at constant speeds. At time t, particle A's position is given by those two parametric equations. Remember our old friend?
Yeah,
Parametric equations?
No, always works on that.
Okay.
No.
And then particle B's position is given by those two parametric equations. All right, find the equation of the line along which particle A moves. So, do you remember how to do this? Well, that's how we got these things right here. So now we're going backwards, okay? And so in order to go backwards and find the equation for a line, we just need 2 points, okay? So what I'm going to do is I'm going to plug in some values for t here to give us an x and a y, and then use those points to come up with an equation for a line. So what value of t would you like to plug in? No. 0. Good. So if I plug in t equals 0, I get x equals 2, I heard over my shoulder, and y equals negative 3. Okay? So that's one of the points on that line. Now I need to find another t value to plug in, and I don't want to use 1 because of this 1/2. Okay? I don't want to use 5 either. Isaiah, you got something? No?
2.
What about 2? Yeah, because I'm just trying to stay away from the fractions. You could use 1, but I'm just staying away from fractions. So if t equals 2, then the x-coordinate is going to be 4, and the y-coordinate is going to be negative 2. All right? So now that I have 2 points, y2 minus y1, negative 2 minus negative 3 is 1. x2 minus x1 is 2. So my slope is 1/2. Okay? Yeah.
Wait, negative 1? Yeah, it's negative.
No, because y2 minus
No, it
y1.
is. It is 1.
Yeah, I know. All right, which point do you want to use? This one or this one? Bottom one? Okay, so then I would say my equation is y plus 3 equals 1/2 times x minus 2. Okay?
Yeah.
Yes. Oh, okay. Then it asks us to graph the line. Sketch the line. So how do you want to do that?
I mean, I really don't.
How should we do that?
Get that,
Do you want to go to y equals mx plus b form? Okay. So if I distribute that 1/2,
actually, if you didn't, would you go right 2 and then down 3?
yeah, what you could do is you could start at this point. go right 2 and down 3. Start right there instead of starting at the y-intercept. And what's the slope? 1/2. So then I would go up 1 over 2, up 1 over 2. Yeah, so that would be my line. And then where is my starting point? It says, sketch the line done, label A starting point. Where's the starting point?
Okay.
Right here, right? So this is start. And which direction does it move? It moves to the right because from there it goes to 4 and -2. Okay? So actually we probably wouldn't have the rest of this line right here because it's just going to start there and go that way. Yeah, right. It would be a ray, not a line. But it says sketch this line. So that's what we did. All right? All right, next one, same deal. Find the equation of the line along which particle B moves. Okay? So if I take and plug in 0 for t, what do I get as my first point? If I plug in 0 for t,
12.
what do I get as the coordinates of my
12, 6.
first point for B? Yeah, 12, 6, because this would be 0 and this would be 0. So my first point is 12, 6. All right, now I need another point. What's a good number to plug into there? 3, because of this 1/3. So if I plug in 3, 2 times 3 is 6. 12 minus 6 is 6, so the x-coordinate will be 6. And then if I plug in 3 here, 6 minus 1 is 5. All right, so now we're going to use those to come up with the equation for a line again. So y2 minus y1 is? y2 minus y1 is? -1. And then x2 minus x1 is -6. Nice job, Megan. So the slope is 1/6. Okay? All right, so which of the 2 points do you want to use to come up with an equation?
That one on the right.
This one?
Yeah.
Okay? So y minus 5 equals 1/6 times x minus 6. All right? And then it says to graph that on the same thing. So I'm going to actually make a real graph of both of them. So the other one started at 2, -3 and had a slope of 1/2. So you guys don't really have to do this, okay? But you can just follow along with me here. So it starts right there and then it had a slope of what? The first one? 1/2. So up 1 over 2, up 1 over 2. And so we decided that that was a ray going in this direction. So this is particle A. Okay, where does the other one start? Where does the other one start?
Right, 6.
But it starts at 12, 6. Okay, so I'm going to start my graph at 12, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6. And then that has a slope of 1/6. However, since the next point we came up with is 6, 5, which way is that point going? To the left, right. So instead of going up 1 and over 6, I'm going to go down 1 and back 1, 2, 3, 4, 5, 6. And that will put us on this point here, 5, 6. And so the other point is, I'm sorry, 6, 5, yeah, thank you. The other point is going this way. Okay? All right, yeah, I was going to say, find the time at which the distance between A and B is minimal. Yeah. Find the locations of particles A and B at this time and label them on your graph. Okay, so how would I find the distance between these two things?
Pretty sure they intersect.
Yeah, they would intersect somewhere up here.
The
But
particles will be different spots on the line.
Is the inner oscillator?
Wait, they wouldn't intersect. They don't intersect.
Because this is t equals 0 right here. Yeah, you're right. And this is t equals 0 right there. Okay, so how do I find where the minimum distance is?
Opposite.
Oh, because you want to do the distance from that point to the other one? Okay,
Well, if that's bottom line continued, it'd probably be up there somewhere.
it seems like it might be right under here, but if it gets here, then that one might be closer. I don't
No,
know.
because that one would be moving.
Okay, well, let's figure it out mathematically so we'll know. We need to use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and what we're going to use as our x2 and our x1 and y2 and y1 are these things right here. Okay, so I'm going to call this x1, we'll call this y1, and we'll call that x2, and I'm going to call that y2. Okay, so if I go x2 minus x1, what is 12 minus 2t minus t minus 2? What is this thing minus that thing?
Oh,
No,
Wait, which thing?
this thing right here minus this thing right here. Negative 3t, and then 12 take away 2 is 10. Okay, so my x's difference is going to be negative 3t plus 10 squared plus what is this minus this? That is going to be gross. What's negative 1/3 minus 1/2? Maybe. Negative 1/3 minus 1/2. This is going to be negative 2/6 minus 3/6. So actually negative 5/6. You are adding them instead of subtracting. Okay, so it's going to be negative 5/6t. And then I have to go, I'm doing y2 minus y1, so 6 minus negative 3 is 9. All right? So there's the distance between those 2 points. Okay? What do I do with that?
can't use the
Distance thing on the calculator? What's the distance?
Distance.
Oh, yeah, but we don't want to do that. We don't want to be mathy. We want to be smart people. Okay, what do I do now?
You would.
Yep, got to FOIL these out. So this thing squared is going to be, bless you, 9t squared. And then negative 3t times 10 is negative 30t, and then I have to double that and get negative 60t. And then 10 squared is 100. This thing squared, 5/6t squared, is going to be 25 over 36t squared. If I multiply those two together, negative 5/6 times 9, 3 goes in here twice, 3 goes in here 3 times. So that's going to be negative 15 halves. Then I have to double that, so that's going to be negative 15. So it's going to be negative 15t, and then 9 squared is 81. Okay? So this is totally awesome. And as a side note, good chance that we're doing this completely incorrectly. So if I combine my like terms, 9t squared and 36t squared is 9 and 36t squared. Negative 60t and negative 15t is negative 75t. And 100 plus 81 is 181. Okay? So this stuff underneath here is an upside down parabola, I mean a right side up parabola because A is positive. So if we want to find the minimum distance, we need to find the vertex of this thing right here, right? Okay? So how do I find that? How do you find the vertex of the, what are you doing? You want to just graph that whole thing? All right. Do you have it written down somewhere? Someone have this written down somewhere?
Yeah, I got it on my paper.
All right, this got a little out of hand, so we'll go ahead and cheat from here and graph this. So I was doing,
9 and 25.
hold on, I got to get into my little fraction mode here. What is that as a fraction? 9 and 25, 36? What's 9 times 36? Probably I can just do that right here. 9 times 36.
Plus 25.
Over, oh yeah. It's what? Did you do the plus 25?
Yeah.
Okay. So what did you get one more time? I'm sorry. 349. So 349 over 36. 36.
Oh, you're outside of the square.
Oh, I am outside the square root. Okay, so got to stay under the square root. X squared. What's next?
Minus 75.
Minus 75
T or X.
plus
Plus
181. Okay. Okay, so there is the little parabola that we get out of that. And what are we looking for? The minimum, the vertex. So I'm going to go second trace minimum. Let's go left bound, I don't know, 0. Right bound is maybe 8. And then my guess would be around 4. And the minimum is when t equals 3.868. Man, that was a lot of work.
We'd be done.
No, we're not even done yet.
No, we.
What do we have to do with that number to figure out, bless you, the locations of particles A and B? What do you have to do? Plug it into what? Yeah, to the parametric equations that we started with. Okay? And so what number is this? If you do that, oh, they just have as their answer actually the t value. What did we get?
3.86.
Love it. Got it right. Okay.
That makes you feel really good.
It does actually, yeah, because there was a lot of stuff to do there, and I've never done these before. Like next year, it'll be easy because I've done it all. I haven't done these before, so you guys are the guinea pigs, yeah, for sure. Don't feel good about yourselves. All right. So last two are simple algebra problems. If I'm going to solve this for t, what do I do? First step is what? Do what now? Nope. Nope.
Subtract 1.
Subtract 1. So s minus 1 equals 2 times t minus 1 squared. Now what? Divide by 2. So t minus 1 squared equals s minus 1 over 2. Now what? Square root both sides. So t minus 1 equals plus or minus the square root of s minus 1 over 2. Now what? Add 1. So final answer, t equals 1 plus or minus the square root of s minus 1 over 2. We got one more, Kenny. You can do it. Do you think you thought, or some of you thought today was going to be free? All right. Oh, look at that. It's an easy one. It is. Quadratic formula. Opposite of b, plus or minus square root of b squared minus 4 times a times c would be 12. Oh, you can't use the calculator. all over 2A. So I don't know if they want no solution for this, or if they want the, which number is this? 20? Wait, why does there have, answer have a Y in there?
Just only for X. Like last
Well, you
part
put
of
X
the problem,
equals-
so you would subtract 30, just like the last one, so.
All right, let's just be
Like
done.
Really?
What?
Probably.
Dude, that's gross.
Let's try it.
No.
Okay, so that means that my A is actually 3 minus Y, not just 3, is that what you're telling me? That is
No, let's
crazy.
not do that. Let's not do
I don't
that.
think that's,
It's fine, just we're done now.
I don't know what they've got, -1 plus or minus the square of Y minus 2.
What, we're gonna just stop.
Yeah, we're done, we're done, we're done.
What? Nothing? Okay. So, since you get a negative underneath the square root, no real solution. All right? Okay, we now are ready to do a little, is that all of the problems from that section, or do we have one more? Did we do, oh, no, we got one more, 16, 17, and 19. 16, 17, and 19. So that starts on page 104.